Next up, we will have Jehun Hong. He will be presenting on fishing free riders using Altruism, zero-sum fitness competition, and prey predator system.
Right. Oh, sorry. Just a second, please. I think there is a slight technical error. I think the screen is not shared. No. So. Oh. I didn't know that.
Yeah, just a little magic.
Thank you very much. Yeah, I'm gonna try it once again. Yeah, that's perfect. Yeah. Hello, it is a great pleasure to introduce our research today to you all. My name is Jehun Hong, affiliate researcher in Human Factor Psychology Lab at Seoul National University, and I'm also in the Juris Doctor program at Sungkyunkwan University Law School. Today, I'm going to present our research, Fishing Free Riders Using Altruism, Zero-Sum Fitness Competition in Prey Predator System. So let's get started. So first of all, I would like to briefly explain the biological definition of the term altruism. Altruism is a behavior by an individual that increases the other's fitness while decreasing the fitness of the agent. So for instance, if someone gives another person some money and just loses his or her money, it can be called as altruistic behavior. So altruism is costly behavior, and why altruism can be successful behavior strategy in human society or ecology is very intriguing question in biology, anthropology, and cognitive sciences. The most standard model which answers that question is the reciprocal altruism theory, which is the essence of this theory is simple. We are helping each other, and we are helping other people because we expect the recipients help when we need help later. In other words, altruism is a successful cooperation strategy with expectation of future reciprocity. Furthermore, since it's cooperation, the main condition of the reciprocal altruism is a efficiency. The benefit of overall cooperation must be larger than the cost of altruistic behavior. However, this model contains some limitations. First, altruistic behavior expecting reciprocity leads to the problem of free rider. When we cannot punish the free rider, the best behavior strategy in the social group is free riding to cooperators, and it leads to the collapse of the cooperation system. However, punishment system is also very costly, so the reciprocity does not provide the stability of altruism. Second, in this model, altruism cannot emerge when the efficiency of cooperation is low or absent. It represents that the altruism only emerges when there are sufficient energy resources from outer space or there are some efficiency as a public goods. Also, cognitive and emotional approaches show that the people tend to give charity without the expectation of reciprocity or a future reward. And this behavior is not adequately explained with the reciprocal altruism model. Some neuroscientists focus on the role of empathy and its neural mechanism, which produces the altruistic mind. But this neural level explanation does not provide the origin and fundamental structure of altruism. So our aim is to figure out the general model explaining altruism. So we propose two conditions. First, no direct reciprocity from the recipient of altruistic behavior. So this condition prevents the free rider and consequential problems and reduces the risk of altruism. Second, the zero-sum game environment. This condition examines whether the altruism can be evolved without extra energy supply from outer space or whether there will be whether the efficiency of cooperation system will be required. Then I would like to briefly explain our research model. Basically, in this research, there are 3 artificial agents, 1 predator and 2 prey. First one is altruist and second one is recipient. And we are going to play the game among these agents. In short, predator gets energy from the predation and loses energy from the concept of investment to altruism. I'm gonna explain it later. And the altruist gets energy from that investment to altruism and loses from the predation and altruism to a recipient. And the last, the recipient gets energy from altruism and loses the energy from the predation. So the very basic condition of this model is that the space is divided into 2 space 1 and space 2. And the space 1 is the place that the altruist agent inhabits. So in other words, the altruist agent is always fixed to the space 1. And I'm going to introduce the first rule of our agent's behavior. The predator agent and recipient agent can modulate their probability of being in the same place with the altruist agent, space 1, regarding the environmental input and to maximize their survival fitness. Second rule, altruist agent can give energy resources to the recipient. So this behavior is altruist behavior, but only when the recipients share the same space with the altruist agent in space 1. And the altruist agent can modulate the degree of altruist behavior to maximize its fitness. Last rule, not only the predator can modulate its location between space 1 and space 2, but the predator agent can invest in an altruistic agent equivalent to the amount of altruistic behavior. They can also modulate the degree of investment to altruistic behavior from 0 to full investment. So in this model, our hypothesis is that the altruism can be used as a bait to fish the free rider, which is called as recipient in this model, and enhance the fitness of predator and altruist agents. Altruism would seduce the recipient agents to be moved on the space 1, and it would facilitate the hunting of predator because it makes prey scattered in space 1, and predator invests to altruist behavior to fish the recipient, like we buy some good baits to fish the good baits to get more fish. And this behavior compensates the cost of altruistic behavior of altruistic agents. So these are the equations that we use in a zero-sum game to calculate the fitness score of each agent. The fitness score means the survival ability in a certain environment. And in our study, we calculated this fitness score by measuring the number of energy resources that each agent has. And also, to model the cognitive characteristics of each agent, we used a neural network for modeling the predator's agent behavior and use simple gradient descent algorithm to model the prey agents. The gradient descent model is used for expressing the direct decision-making of prey agent because they instantaneously change their behavior strategy without investing in the future reward or thinking of future actions. However, to examine the effect of long-term decision-making capacity of the predator, we used a neural network with one hidden layer, very simple model, to model the general decision-making of a complex brain system or a human behavior. So in our study, the experiment factor is the long-term decision-making capacity, which represents that whether the agent can make the decision with thinking of future rewards and maintaining such as long-term investment. In our study, the capacity is measured as the time length of future action, which is expressed as the variable x in our experiment of predator, which means the time length of maintaining one behavioral strategy or one behavior strategy regardless of environmental change. So we measure the fitness score and the behavioral outputs such as altruistic behavior, location change, and the investment to altruism with the 8-level condition of the time length of future actions of predator agents, from changing strategy every single moment to maintaining one behavior strategy if decided initially. So let's see the result of our study. Altruistic behavior value is increased in the high-level condition of the time length of the future actions of predator agent. And we can imagine the fitness score of an altruistic agent would be decreased because the altruistic behavior is costly. However, the results show that the fitness score of the altruistic agent is rather increased, but the recipient's fitness score decreased. So why? We measure the investment in altruistic behavior from predator agents, and they invested more when they have sufficiently high long-term decision-making capacity and their cognition. It is also a costly behavior for predator agents, but in that condition, the fitness of predator agents rather increased. So we found the reason that the predator's fitness increased in the condition is that the recipient agent is gathered to the space one where the altruistic agent resides. And also, as long as the heterogeneity of spatial distribution of overall prey agents occurs, it reduces the risk of uncertainty of hunting for predators. So it is worth for predators to invest in altruistic behavior of prey agents to use this as bait to get more prey in one space. So from our result, we concluded that this model represents the predator's long-term decision-making capacity that enhances the prey's predator's long-term decision-making capacity enhances their prey's altruistic behavior. For the long-term investment, predators used altruists as bait to fish more prey. In this model, the recipient prey, exactly. And in this condition, the altruist agent makes more altruistic behavior because predator gives the reward to altruistic behavior of the agent. And since the recipients are not long-term decision makers, this agent is just observing that other agent is giving some food or energy to them when they move to space one, and they increase the probability of being in space one with altruistic agents. So they just obtain the benefit from altruistic behavior, but they do not have the cognitive ability that expects the predators to be waiting for them in space one. So in conclusion, the recipient's free riding behavior makes it to be defeated in the zero-sum game. So in conclusion, this model can be interpreted as the interspecific cooperative hunting between altruistic prey species and the intelligent predator species. Altruists gather more prey for the predators, and the predator gives rewards to them, such as not eating them. And victims should be the free rider prey species in this model. And this model also suggested that the condition of altruism can emerge even without the direct reciprocity that makes free rider and punishment problem. And also it shows that the altruistic behavior can be a successful strategy even in zero-sum game. The efficiency of cooperation is not guaranteed, and the environment is very extremely competitive among the agents. Finally, our finding is that the cognitive capacity of third-party investors to altruistic behavior, not just the altruistic mind of the altruistic agent itself, would strongly affect the emergence of altruism. Thank you so much for listening. And if you're interested in our lab or our research project, please contact our website or just contact me. And if you want to read the full paper of this study, please use this QR link and feel free to ask any question or give comments. Thank you very much.
Hello, great talk. I just have a quick question. I guess not completely related, at least in some sense. I was wondering that you're kind of like modeling animals' behavior, and it's although not directly related to reciprocity, there's a lot of things though about external reward. For example, you benefit from somebody else and then you lost your energy by giving to somebody else. It's very external driven, but I feel like for humans, there's something very intrinsically, you're like very much intrinsically motivated to do that, such as that if you don't commit altruism in some situation, you feel internally punished. That's a little bit different from how. Oh, I guess I just quite like I just like wondering if you guys have ever considered like to model like maybe like even internal driven motivation to give altruism, because right now in this case is more like you give altruism, you expect reciprocity from some indirect agents.
Yeah.
Thank you.
Thank you for very good comments, and I think that there will be several models that can explain the altruistic behavior and its motivation. And in our model, we wanted to focus on the inner motivation. Not sorry. We in this model we aim to specify the mechanisms of altruism driven by the investor of altruism. So it is the external motivation, I think, but I think that there are a lot of models that explain that the altruism can be emerged with our empathy or social to make the costly social signaling or anything else. So I think that I don't know, it might be a good answer to your question, but I think that maybe this is an ongoing research, so that the further research can be a way to concern the both the internal motivation and an external motivation of the altruistic mind and the investor's mind and their cooperation, I think. Thank you.